Section 13.1, right angle trigonometry, essential question. How do I use sine, cosine, and tangent functions? A trigonometric function is a function whose rule is given by a trigonometric ratio. A trigonometric ratio compares the lengths of two sides of a right triangle. The Greek letter theta is traditionally used to represent the measure of an acute angle in a right triangle. The values of trigonometric ratios depend upon theta. So a lot of this should be a review from geometry. And the one thing I'm going to write over here is so goes with sine, ka goes with cosine, and toa, so ka toa. I'm going to write that a lot because as we look at this, we can see that sine represents opposite over hypotenuse. It's the ratio of sides of a right triangle. Opposite O, hypotenuse H. Cosine A is adjacent, H hypotenuse. Tangent, O is opposite, A is adjacent. So when you're looking at a triangle, theta, in geometry, I guess I don't know if the teachers still teach it this way, but they used to call this the hey, look at me angle. Hey, look at me angle, because that's the very important angle. So this is what everything is based off of. Hypotenuse is always the side opposite the 90-degree angle. So that is a always. So if I look at this triangle right now, the 4 over here, that's opposite the hey, look at me angle, opposite. The 5, that's the hypotenuse because it's opposite the 90-degree. And the adjacent, I call it the one that's touching the side with the hey, look at me angle. I know the 5 is touching 2, but that's the hypotenuse because it's opposite the 90-degree angle. And then we just do the ratios and reduce them. So the triangle shown at the right is similar to the one up in the table because their corresponding angles are congruent. So as you can see up in the table, sine is 4/5. Down here, sine is also 4/5 sine theta. The values of the sine and other trigonometric functions depend only on angle theta and not on the size of the triangle. That's why I wanted to point this out. Because as you can see, the sides of the triangle in the table are different than the sides in this triangle. The reason that the trigonometric functions are going to be equal is because the angles are congruent. Example 1. Find the value of sine, cosine, and tangent functions for theta. All right, here we go. I'm going to always do this. So, ka, toa. And I recommend you doing that also. I'm also going to label my sides. There's my hey, look at me angle. So the side opposite that is the opposite side. There's my 90-degree angle. The side opposite that is always my hypotenuse. It's not letting me write over here. Let's try that again. Okay. This side is the hypotenuse. And this side is the adjacent side. Side that's the side that's touching the theta angle. Now, once you do that, everything else is quite easy. So here we go. O, which is 30, over H, which is 34. And you always want to reduce these. So 15 over 17, because 2 can go into 30 and 34 to reduce it. Cosine, adjacent is 16, over hypotenuse is 34. And if we reduce that, 2 goes into 16 and 34. And you'll have your calculator to reduce these. And tangent, that is going to be adjacent, toa, O, opposite, over adjacent, which is 16. Oops, I gotta scroll down here. And that reduces to 15/8. Just double checking. It's exactly what it is. All right, example 2, or no, now we're going on to something different. Special right triangles. You should have also learned this in geometry. There are two kinds of special right triangles. There's a 45-45-90 and a 30-60-90. When we talk about 45-45-90, the length of the hypotenuse is the side opposite the 90 degree, is the square root of 2 times the length of a leg. Now, I was told by some of the geometry teachers, I've never taught geometry, that in geometry, they call each of the legs L. So therefore, the hypotenuse then is L root 2. So I'm trying to be consistent and want to make sure that I can be to make your life as easy as possible. 30-60-90, the length of the hypotenuse, again, the side opposite the 90 degree angle, is 2 times the length of the shorter leg, and the length of the longer leg is root 3 times the length of the shorter leg. And again, geometry teachers told me that they call this side S, this side 2S, and this side S root 3. If you want to use X, that's fine. Also, here's what I want to point out. On the 45-45-90, obviously because these angles are congruent, that's why the side opposite the 45 is L and the side opposite the 45 is L. They're equal to each other. And then the hypotenuse is L root 2. On this one, it's a little different because it's a 30-60-90. So the side opposite the 30 degree angle, that's what you want to remember, is S, or if you want to call it X, it doesn't matter. The hypotenuse is always double that shorter side, and then the longer leg is just going to be S root 3. Let's do an example. Use a trigonometric function to find the value of X. Well, right away we know this is, a 45-45-90 because 45, there's the 90, and the sum of the angles have to add up to 180. So right away, we know that this is going to be L. See, this is going to be L. The other side over here is going to be L, but my marker is not letting me write that. And this is going to be L root 2. Okay. I am going to just quickly draw this over here because it's not, my pen is not letting me go over there. There's 20. So this is going to be L, L, L root 2. Sorry about that. Okay. All right. So let's fix that really quick. There we go. And we're trying to find X, which is, they're calling this side over here. So I'll just go like that. That's our X. Well, the side we know is the side we're going to start with. We know this side of a 45-45-90 is L root 2. So I'm going to set L root 2 equal to 20 and solve for L. So divide both sides by square root of 2. L is equal to 20 over root 2. And we're going to rationalize the denominator because we don't leave a radical in our denominator. So we have 20 root 2 over 2 because 2 times 2 is 4 and the square root of 4 is 2. 20 divided by 2 is now 10 root 2. So we found L, and we know that L is equal to X, so we know our answer. Our answer is just going to be 10 root 2 right here. 10 root 2. All right. right, example 3. This is a 30, 60, 90. Because if this is 30, then obviously this is 60. And this is 90 because they add up to 180. And again, if you recall, we call this side S. This is 2S. And this is S root 3. On these 30, 60, 90 triangles, you always start with what you know. We know 74 is the hypotenuse, and we know that is equal to 2S. Divide both sides by 2. S is equal to 37. So that is our X value. There we go. All right, caution. Make sure that your graphing calculator is set to interpret angle values as degrees. So on your graphing calculator, you're going to press mode. You're going to check that degree and not radian is highlighted in the third row. Here we go. Example 4. A skateboard ramp will have a height of 12 inches, and the angle between the ramp and the ground will be 17 degrees. And that would be right here. To the nearest inch, what will be the length L of the ramp? We're trying to find this right up here. This is not a 30, 60, 90 or 44, 45, 45, 90. So we're going to be using SOHCAHTOA. So let's write that out. So get in the habit of doing this, and we're going to figure out which one we're going to write, which one we're going to use. So we're given an angle, and we're given the length of the side opposite the angle, so the O, and we're trying to find L, which is the hypotenuse. So if I come over here and I look at my options here, if I know O, I'm going to use either sine or tangent. Well, I know I'm going to use sine because I don't care about the adjacent side. I want to find the hypotenuse. So here we go. We know that sine of 17 degrees, so this is the one we're using, is O, which is 12, over L. And what we're trying to find is L. So now what we're going to do, well, whenever you have a fraction, you want to get rid of it, you multiply both sides by the denominator. So now we have L times sine of 17 degrees. These cancel. And now we're going to divide both sides by sine 17 degrees. And I'm going to scroll down. And on your calculator, I'm going to write this out, I guess. You could type the whole thing into your calculator, but sine of 17 degrees should be, when you type it in, 0.2924. So make sure you try that on your calculator. And that's if your calculator has to be in degree mode. And when you do that, you will get 41 inches. There we go. When an object is above or below another object, you can find distances indirectly by using the angle of elevation or the angle of depression between the objects. So as you can see by this picture, we have this airplane up here, and we have this tower down here. If we're talking about an angle of depression, there's the horizontal. That plane we're drawing a line looking down, that would be the angle of depression. The other side, again looking up, is angle of elevation. Well, these angles are going to be congruent to each other. So here's an example. A surveyor whose eye level is 6 feet above the ground measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.7 degrees. If the surveyor is standing 120 feet from the hill's base, what is the height of the hill to the nearest foot? So bear with me with my drawing. So here is our person. And our person, I'm going to go like this, is 6 feet tall. There's that. There's our triangle here. There's our right. Okay. We're going to obviously call this the hypotenuse. There's our angle. So this is our opposite. And this is our adjacent. All right. So a survey whose eye level, so the eye level is 6 feet above the ground. That's where I got that 6 feet, eye level. Measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.7 degrees. So this angle right here is 60.7 degrees. That is our theta. If the surveyor is standing 120 feet from the hill's base, there's the base, so this is going to be 120. What is the height of the hill to the nearest foot? Well, height. This is the top. This is the top of the hill. So the height is this distance right there. That's what we're trying to find. All right, so I'm going to go over here and do the SOHCAHTOA. We're trying to find, we don't care about hypotenuse at all. So that tells me which one I'm going to use. So and ca, sine and cosine, both use hypotenuse. I don't need hypotenuse. All I care about is the adjacent and the opposite side. So I'm going to use tangent. So tan of theta, we know theta, 60.7, oopsie, not percent, degrees, is equal to, it's going to be, I'm going to write this out. It's opposite O over adjacent. All right, so that's going to be opposite. I'm going to actually move down here. Now let's plug it in. Opposite, we don't know. Adjacent, we do know. Again, when we have a fraction, we multiply both sides by the denominator. That cancels. And now we're going to take 120 times tan of 60.7 degrees, which is going to give me 214 is equal to x. So let's scroll up a minute. This right here is 214. They want to know what is the height of the hill to the nearest foot. Well, if you think about it, this is only part of the height. You got to think about where the person is standing. This is the ground. So let's draw a little line here. This is the ground right there. So we need to find the total height. This is only 214 is only the distance from here to here. Well, we already know the person is 6 feet. That's 6. So get the total height of the hill. We have to take x plus 6. So 214 plus 6, which is 220 feet. That is the total height of the hill. So reciprocals of the sine, cosine, and tangent ratios are also trigonometric ratios. They are trigonometric functions. They are called cosecant, secant, and cotangent. And basically all these they're not difficult. You just have to know how to flip. Take a reciprocal. So cosecant is the reciprocal of sine. Secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. So it's easy as if sine is 4/5, so if sine is 4/5, then cosecant is 5/4. The 5 goes on the top, the 4 goes on the bottom. Same with secant and cotangent. Example 6, we're going to save for class. And here are your video questions. please pause the video and write them in your notes.